Hello, good morning, everyone. Hello, good morning, everyone.
Good morning.
Okay, are you getting my voice clearly?
Exactly.
Thank you so much. Let's get started. And let me know if you see my presentation. Do you see my presentation?
Yes.
All right. So today we are going to see just a brief introduction to statistics. As you know, last time we have gone through introduction to research. We have explained why we do research and why research matters. We have explored parts of writing an article and have outlined the importance of three parts of an article. You have to have a problem to solve, and you have to have a good instrument, and then you have to have implication of that results. Okay, and in method, so that you can perform that research, you need to collect data. Therefore, you need to analyze data. So in social science or education, we must use statistics and some software such as Excel, SPSS, R, and other. So today, we are going to see how, which kind of tests can we perform so that we analyze our data. And so, first of all, what's the statistics? This is a way of analyzing quantitative data, actually, right? But also have qualitative data. These data are in the form of words and pictures, but not in numbers and not in categories. Example of survey, such as a narrative interview, group discussion, whatever. And quantitative data is expressed in numbers. Example is when you collect the student test scores, or time of instruction, teaching method employed, like that. And you may have category, as we are going to see, the types of data. Category, you can categorize your numbers, like gender. You may want to investigate impact of gender maybe on test results. So you can split this test score among male and female, and you see the difference. Same as nationality, same as courses. Now, in statistics, we have basic two kind of tests. One is parametric, another is non-parametric. How are these? And these are take us to explaining three types of data. Three types of data. We have scale data, we have categorical data, and we have ordinal data. So parametric test exactly test for scale data. So scale data are also called ratios or intervals. Intervals such as temperature, years, and ratios such as test score, age, height, weight, income, time, or duration. Okay. And this data should be normally distributed. Sorry? Do you still hear me? Hello?
Yes, we are listening.
All right, let's continue. So normal distribution is one among five assumptions of parametric tests. We are going to see it soon. And what about non-parametric tests? Non-parametric tests tests for nominal or categorical data. Example, countries. Example, gender. Example, teaching method. Example, race. And when it comes to ordinal data, is just ranks. First student, second student in a class, satisfied, neutral, dissatisfied, like kind of uh, Likert scale data. So let's have examples here. You have seen a scale data is like something like time, score, length, weight, and ordinal data is a kind of rank. So you can have both in your data. Let's see this example. Some people are running, right? A marathon. You can see Anne is running 0.5 meter, Betty 1 meter, 34 meter, Daisy 5 meter. But the lengths are here. These are not the length these people are running, but the length, each one is ahead of another one. So for example, Anne is more advanced than Betty. See, Anne is here, Betty is here. Anne is more advanced by a half meter than Betty. So that is the order. That is a rank. That is ordinal data, right? When you put things on online or on order. And what about the scales? So the scale can be the distance between Anne and Betty, which is 1.5. So this is the number. This is a scale. So in this example, Betty is number 2. Betty is 4 meter behind Anne. Betty is almost same as Anne. Like, so you can just take a look on data and analyze as you see. All right, here we have the assumptions, and among these two big tests, this kind of tests, parametric and non-parametric tests, we have several exact tests we can perform into our software. Like, you need to use parametric when your data are interval or ratio, scale data, all right? And you have to use parametric when data are normally distributed. You have to use parametric tests when there are no outliers in your data. You have to use parametric tests when you have equivariances. And you have to use parametric most important when you have enough data. Enough data is when you have a sample larger than 30 participants. And what about these parametric tests? We can use independent sample t-test. We can use paired sample t-test. We can use one-way ANOVA. We can use one-way repeated measures ANOVA. We can use Pearson R. And what about non-parametric? We use non-parametric tests, such as Mann-Whiting tests, such as Wilcoxon-Sein-Lang tests, such as Kruskal-Wallis test, Friedman ANOVA, Spearman R, when we failed to assume, when parametric tests failed, right? When the assumption for parametric tests failed, such as when you have nominal or ordinal data, when you don't have interval or ratio or scale data, like when we have other people in categories, so we use non-parametric. So we can use non-parametric, even if we have scale that when data are normally distributed, when you have outliers in our data, when you have variances which are not equal, when you have a small sample, less than 30 participants. So even though you have scale that, but data are not normal, you have outliers, variances are not equal, and you have small sample, then you can go ahead and use parametric test. Okay. So as we arrange them here, it means instead of using independent sample t-tests, when you don't feel like the assumption required for parametric tests, instead of using independent sample t-tests, you use man-Whiting test. We can see them clearly in the SPSS in our future training. And instead of using paired sample t-test, we can use Wilcoxon signed rank test. Instead of using one-way ANOVA, we can use Kruskal-Wallis test. And instead of using one-way repeated measures ANOVA, you can use Friedman ANOVA. And instead of using Pearson R, and you can use Spearman R. This Pearson R is used in validating your instruments, such as test-retest. And Spearman R is used for non-parametric, such as Cronbach alpha, when you are checking your attitude scales. So this table is very important. If you can screenshot or take a picture of it, then it will help you in the future. When you get the data and you see assumption, then you know which tests you need to use. All right. This is just a quick of showing how to validate your data and which test you use, as I said. When you have scale data, you need to use Pearson correlation, most used in experimental studies. Experimental studies when you have control and the experimental group. And Spearman and Kendall's style are used for ordinal data. They are most used for rating questionnaire, like Likert scale or attitude scale. All right, so here I put this figure. This shows a normal distribution, a normal curve, and you assume that a good data should look like this. Now, as you know, when we analyze data, we first analyze this some basic statistics, such as mean, such as range, mode, median. But when you need to compare something, so you need to check inferential statistics. So we can use the inferential statistics to answer some question like, is what is true in sample true in whole population? Like, now here is an important, very important table too. You can take a screenshot, picture of it, and it will help you a lot. So, you know, mathematically we have dependent and independent variables, dependent on y-axis and independent on x-axis. Economically, we have input and output. So when you have on independent variable, we have a scale data. And on dependent scale axis, we have scale data. So the tests we use are just correlation and regression. But when you have categorical data on x-axis, but you have scale data on y-axis, we use t-test and ANOVA. If assumption don't apply, then we use equivalent non-parametric test. And what about when we have categorical data on both x and y-axis? So we use chi-square test. So this is it. And maybe we can explain this using board. Do you still see my screen? Hello.
Yes, yes, can see it.
All right.
Hello?
This is the one we've been observing. Have you changed this?
Do you see my yellow screen? No?
No, we are still seeing the slide you shared
Presentation?
before.
Oh, sorry. All right. So do you see my yellow screen?
It's sharing, yes, just seeing it.
Right. All right, let's explain what I was telling you on the presentation. Probably that's theoretical. I like this table. And first of all, mathematically, we have x-axis and y-axis. And you will face this arrangement in all data analysis you see. And let's say we have this is the independent variable, and this is dependent variable, because on y-axis that depend on your independent variable, right? And our data said when you have independent variable here and you have dependent variable here, when you have, let's say, scale data here, scale data such as test score on independent variable scale, and on dependent variable you have scale data. Someone can give me an example of that? One example is when you have, like, you want to check math score and maybe physics score. So you need to see if math score depends on physics score. So if the dependence is positive, you can get a line like this, positive line. Because if you get a low score in physics, it means you also get low score in mathematics. If you get medium score in physics, you get also medium score in mathematics. If you get high score here, because here is 0, then you have also high score mathematics. I think people who combine some courses such as biology, chemistry, physics, mathematics should do such study to see if these things are correlated, because here these are scores. So that's why scale. So the tests which are appropriate are just correlation and regression analysis. Okay. And now, if you have an independent variable, we have categories, categorical data. We have seen categories that such as gender, teaching intervention, whatever. But on dependent variable scale, or on independent variable, we have scale. So in this case, we use t-test and we use ANOVA. Now, but it depends on time. We have, let's draw here. Here we have a male student and a female student. This gender, right? These categories on the x-axis. But here we have math score, okay? So we need to see who among male and the female student perform better in mathematics, right? So we can see when you perform in the software, you can see a figure like this and a figure like this. In that case, we find that female, this is just example, female perform better than male at what extent? This extent, right? If you scale here, then you can see the difference between male and female performance, right? So these are basic statistics. We can calculate means, standard deviation, whatever, median and mean, and you can see with our eyes the difference, right? So, but you see, how many variables we have on x-axis? Just two. Actually, is one variable, which is gender, only split or have two levels, male and female, right? So we have what we call independent t-test and paired t-test. These are independent t-tests because male and female are two different people, right? But what happens if we have just male here? Male, just male, not female. But here we have let's pre-test and the post-test. Probably this male can have such a pre-test, and in the post-test can have this one. But same, so this one is the difference between pre-test and post-test performance. So this is the paired independent sample because pre and the post are just one score, only that the
Sorry,
time
no, I'm your teams,
is different. Now, you can see for t-test, we just have just two levels. What will happen if we have more levels? ANOVA is coming, analysis of. Let's say we have on this, we have male and female together. T-test can't perform such a robust analysis. In that case, we use ANOVA. Let's say when we have male, female, but you have both pre and post test. Right? So we can see a figure like this. Like this. Then you can say maybe during the pre-test, female and the male had this similar scores, but at the post-test, we got a difference. Let's say if this one, oh no, all right. So we can label this here like this, maybe female, and maybe this one male. So in that case, you can see though male and female at pretest had similar score, but at post-test got different score in favor of female. So you see, this figure analyzes same thing, same time, difference between male and female at the pretest, same time at post-test. So this analysis can't be performed by independent or paired t-test, because t-test just compare two things, while ANOVA can perform more than two things or two things repeated. So that's why kind of this figure is called repeated measures ANOVA. All right, we have one way ANOVA. When, let's say here is math score, but here we have maybe male, we have female, and you have unspecified. So you see, in gender, you have two, we have more than two categories. In this case, we use one way ANOVA. Independent or dependent t-test can't perform this one when you have more than two categories. So we use one way ANOVA because we have three categories. We can also have other categories such as teaching method. Let's say this one is traditional. This one is ICT based, and maybe this one is improvisation. All right. So when you can get a figure like this, and a figure like this. In that case, you can say, depending on teaching method used, ICT is showing more results in math score, and then improvisation follows, then traditional provides less results. All right, so this is how we do. And we have other versions of analysis of variance such as multivariate or MANOVA and UNICOVER. So you can do further research to attain that. Now let's go to another category. When we have categorical data on dependent variable and categorical variable, so we use what's called chi-square, and you can see this figure or this term in many article you read, and when you find it, know that maybe in that research, the author analyzed categorical versus categorical. In which sense? There is instance when we have like we have male, all right? You have female. This is category, but also on y-axis, we have maybe a traditional method and maybe ICT method, teaching method. Also at the categories, no more score, right? So we need to see how male and female perform when traditional method used, right? At the same time, we need to see how male and female perform when ICT method is used, right? Oh, we have another example, right? In the US, they have some parties called Democrats and Republican. All right, you may say, how many males are Democrat and how many female are Democrat? At the same time, how many then male are Republican and how many female are Republican, right? So here we are no longer dealing with scale. So we are just dealing with categories versus categories. So in that case, we use pi squared. All right. So in brief, this is what I wanted to share with you. Unless you have a question for clarification, otherwise we will perform these tests in our future training using Excel and SPSS and probably with R. But if you have this picture in your mind, then you can see, you can collect the data you want, and you can look in any data, then you know which test is appropriate and how to perform it and what output should look like.
ku buryo rero bigoye mwe mugwa mudutemberera mugatwene esa uga ngaha nawe ati mba nk'ubu urupangu nyene ubu aha nyene aha yego
Yeah, I will share the PowerPoint, no problem. Was that clear, or you have some question?
About what? About your explanation?
Yeah, about what we presented, or maybe what I missed. Someone want to learn about kind of statistics, or like test to
No,
be.
all are clear.
Okay. Do you have some teachers here? Secondary school teachers.
We are all teachers.
No,
Not
I mean secondary school teachers. You can see Juliet. Yeah, all right. I think what thing I should remind, research is not for university lecturers and researchers or postgraduate students. As I mentioned last time, I encourage also teachers from secondary school to start thinking about doing research. It's easy for you to collect the data because you are in schools. So if no question, then that was maybe a good start of our future software data analysis. And maybe we can close our training for here and wait for future training. And thank you. Bye-bye.
bye bye hello
Bye bye. Thank you.